I love it.
All right. Hello, and welcome to the first episode of the Unevenly Distributed podcast. I'm Josh Lee. I'm a developer advocate at Altinity. For those who are not familiar, Altinity, we provide hosting and services for open source ClickHouse. And typically, this podcast is going to be hosted by myself and our CEO, Robert Hodges. He wasn't able to make it today, so it's just myself and our amazing guest, Brad, who I'll introduce in a moment. What we want this podcast to be is a conversation on the topic of real-time data lakes, which is kind of a lot of buzzwords, but I think it actually has some significance, and it's sort of a new architectural framework that wasn't really possible before the last 5 years, I think. And Brad has really kindly offered to kind of introduce the topic to us and also tell us a little bit about Tower. So Brad, hi, welcome. Would you like to introduce yourself?
Hey, yeah, sure. I'm the CTO and co-founder over at Tower. Tower is serverless Python infrastructure for data scientists and data engineers. And, a lot of what we do is help folks move into data lakes using like new table formats like Iceberg and all of that, which we'll get into a little bit more as we go. But my background is in data warehousing broadly. I've worked in loads of startups and loads of different companies as like head of engineering and done a lot of data warehousing work. And so I've seen a lot of how the ecosystem has evolved over time and what are the latest trends are and all of that. So I have loads of opinions.
Okay.
That I'd be happy to share. Yeah.
That's perfect. That's exactly what we want. So I guess to start, I mean, we this is really the first episode, so we need to go all the way back in time and tell the whole story. So can you take us back to the early 2010s and like what was happening then? This is, sort of the beginning of my career in DevOpsy things. And yeah, what was big data like?
Yeah, I mean, big data, that term didn't really quite exist yet in 2010. I mean, if you think about the internet, like the social internet was just like coming around, and that's when, data volume started to really grow for people. Before this, data warehousing was something that was like companies did to centralize their data and help them make better decisions about, how their company should behave and all of that stuff. And so like quote unquote data warehouses existed for a long time before that. Companies like Teradata, for instance, you would buy like hardware that you would put in your data center that helped you like accelerate your data warehousing workloads, right? But yeah, with the advent of the social internet and with the world sort of quote unquote coming online, data volume started to grow like crazy. And so people started to look at like the legacy vendors. At the same time, there was also sort of the relational databases, Postgres, MySQL, were both like big vendors in the space, and people would kind of use them as data warehouses, right? But like these single node solutions like didn't really scale the way that they needed them to. Some dudes at Yahoo and some dudes at Google invented this concept of MapReduce, which allowed you to kind of operate over like really large data sets in a distributed fashion. And that's kind of where Hadoop is an implementation of MapReduce, right? And, to do MapReduce to store really large data sets, we needed a distributed file system, some that could store data across multiple computers, right? And so Hadoop is really HDFS, the Hadoop file system, plus a MapReduce implementation. And that's kind of like how Hadoop and big data sort of came onto the scene. But yeah, it was driven by the fact that like more, suddenly companies went from having, hundreds or thousands of users to having millions of users, the internet interacting with their applications and needing new ways to like derive insights from their data.
Yeah, absolutely. So now we have this volume of data, and we're starting to call it somewhere along the line, we start calling it a data lake. And it starts to seem like the answer. Yeah. It seems like there clearly was a lot of value. Obviously, the data volumes was the driving demand, and there was a need. Was there any aspect of it that was in it originally like overhyped? Like what were the initial growing pains?
Well, I mean, like the concept of a data lake actually didn't appear till a little bit later. I would say like, the peak Hadoop hype was like 2014, 2015, I remember going to Strata in New York back then, and it being this huge conference. It was this big data conference, and data lakes were just sort of emerging then. The concept of a data lake, for people who don't know, I'm sure there's some people in the audience that are like this, is this concept of like, I'm going to put like this big like distributed file system like HDFS or S3 like we use now, where you can write data to it and figure out what to do with it later. And it's kind of a lake because like you can kind of like, I always thought of it at least like a lake because you can kind of scoop water data out of it and examine it. And, all this data is kind of mixed together in this one big place, right? So the concept of like data lakes, like the first kind of set of big data jobs, Hadoop jobs, were very structured in nature, like log data from like services or whatever that you needed to compute something very specific from. This idea of like, we'll store it and like examine it later, like data lakes came along like a little bit after, maybe like 2016, 2017 is like around that time frame. And I think we kind of have this like hangover still to this day of the amount of data that companies like maintain. Like the value that people are deriving from it is kind of like decreasing relative to the volumes that they have. Like there's a company that we have in our pipeline. They have 1,000 petabytes of data on tape in their data warehouses in their data centers. And they're like, what do I do with this data? They're paying to store this data and all of that, but like it's just sitting there. And so they're now in 2025 trying to figure out like what to do with this. And this is like transaction data going back to like the 70s probably, right? So this is like probably an extreme example, but this is where like the promise of data lakes, well, actually maybe they over delivered. Like the promise was you can stick your data somewhere and come back to it later. Well, here we are 25 years later trying to figure it out.
Now we're at later.
Yeah, now later. It was a later me problem and now it's later.
Yeah. Okay. Okay. So when did you first realize that this approach of just like throw everything in and figure it out later was causing more problems than it solved?
Well, I mean, I wouldn't say it's causing more problems than it's solved. I think it's definitely like it's delivered in a lot of ways. But I've noticed that it was definitely causing problems. Yeah, when I started to talk to customers like that. Also, like before doing Tower, I had worked at Snowflake, and I think it's pretty public knowledge that most of like Snowflake is a massively scalable SQL data warehouse, right? But most of the active like data that people use on a day-to-day basis is like typically like a very small percentage of their overall data estate, Like I don't remember the actual figures, but I want to say like, the working set that people use to like drive their business is like typically less than like 1% of their overall like the overall data they maintain. So if there's a place where the data lakes are problematic, it would probably be somewhere in that realm, right? Of like, you need to have a way of like, yes, you want to retain data forever, but maybe having a way of like aging out the data you don't need is like the problem we need to solve for humanity. There was like this Reddit article I saw the other day, or maybe it was yesterday, of like some folks in like California, maybe, I can't remember where exactly, being encouraged to delete emails from their inbox. So that as a way of conserving water, data centers need water to be cooled. The more emails you save in your inbox, the more data center space gets consumed by like Google, whoever, right? And so like, not to be dramatic, but like maybe there are like real impacts from like this data lake approach, keeping data around forever, etc. Yeah.
My iPhone dutifully backing up my last 10 years of text messages over and over again. Yeah.
Okay, it adds up over time.
And you mentioned, I noticed that you called Snowflake a data warehouse, not a data lake. And I'm wondering if you've seen like a reverse migration. So we've seen this in the cloud a little bit, right? Like everybody kind of ran to the cloud, and now a lot of companies are kind of evaluating the costs and the benefits and moving back to on-premise. Are you seeing the same thing with like data lakes and data warehouses, where companies, I like what you're saying about doing it right, but are some companies just sort of abandoning it?
I wouldn't say they're abandoning it, but there's definitely like a pendulum. Like in this episode, we'll talk about pendulums in a couple of dimensions. And there's definitely a pendulum that happens in the data ecosystem with regard to like centralization and decentralization. And like the Snowflake Databricks like migration that we're seeing is a centralization migration. Like they both built these amazing SQL-driven technologies. We call them data warehousing technologies because they're SQL-driven. They behave like one big sort of data warehouse. That's why they call them a data warehouse, I guess. And this was super useful for vendors. Yes, it behaved like a data lake. Snowflake kind of behaved like a data lake too, in that you kind of just dumped all of your data into different tables in Snowflake and figured it out. Now you're paying a Snowflake bill instead of an S3 bill. But like there was this movement, I think, like the Hadoop, open Hadoop ecosystem, like the pendulums, like if you think about it, like I mentioned, like the Teradata like ecosystem, like the pendulum swung into the open ecosystem with Hadoop, and then it kind of swung back into the closed ecosystem again with like the Snowflake and Databricks revolution. And I think we're in the process of seeing it swing back with like open Lakehouse and people having more of an appetite to build their own data platforms. Yeah.
Okay. And with each one of these pendulum swings, like what are we losing and what are we gaining?
I mean, I think there's some really like practical things, like for instance, like the build it versus buy it sort of trade-off that you have to make. Snowflake's an amazing technology. The fact you can go give them a credit card and have like a world-class data platform, like out of the box, is like crazy, right? Like that's something that no one ever had access to in the history of humanity, right? And so easily. Trying to build something like that in-house is a bit crazy, unless you're like the biggest cloud native, players in the world, like Netflix or Pinterest or whatever, who'd like actually go do that. But again, the pendulum swings back towards the open side because people want more control, specifically control around costs. These tools are super expensive relative to like the things that you get out of them. Oftentimes, again, you store all your data in Snowflake, you use 1% of it, but you're still, beholden to that bill. The paradigm shifts also drive like a need for new technologies to a certain degree, drive this pendulum to a certain degree as well. Like the workloads are different now. People, instead of like applications querying databases like Snowflake to get data and to power the application, that data looks more like I've got a collection of video files that I need to feed to a model, or I've got like a whole streaming audio coming from like a like security system that I need to do anomaly detection on. The types of data is changing, and like the traditional tools, like I'm sure that there's like a Databricks like account executive somewhere that's going to be jumping up and down saying you can do this on Databricks, but like the world is like building different tools now for a reason, right?
Yeah.
And yeah, actually, like I was kind of doing a little bit of prep for this podcast, and like was reminded that like one of the big drivers for the open data lake is indeed like these AI workloads, like just don't fit the traditional data warehousing workloads very well. So yeah.
Okay, I like it. And it does seem like we're in a pendulum swing towards the open, and you're calling it an open data lake, which I love. I have some opinions about the term lakehouse, which we haven't defined, but it's sort of
true.
for those not familiar, it would be that idea that snowflakey kind of looks like a warehouse, but has the scale of a data lake thing, right? That would be a lakehouse.
Yeah, exactly. I mean, I define a lakehouse. I mean, there's probably much better definitions online, but I define a lakehouse as it's sort of like a data lake, but where everything is much more consistent, stored in a single format. There's usually a metadata layer that helps you determine what's in the relevant data lake or in the lakehouse, but it's open using open formats, like I mentioned, such that multiple engines can go and query the underlying data without like having to do a lot of heavy lifting from the engineer's perspective. Again, back in the Hadoop sort of that data lake world, you knew the relevant data was in your data lake, but you'd have to write maybe a Hadoop job to like normalize it in a specific format so you could get something out of it. But if you just store everything in a consistent format from the beginning, then you can point any tool at it. And that's like the magic of the open Lakehouse, is like being able to pick the best tool for the job to service your customers. Yeah.
Okay, so you mentioned formats. So can you introduce us to some of the open formats that are available?
Yeah, absolutely. This is a topic that I really love. I don't work on formats personally, but I just love storage formats. I don't know why. I think they're kind of part of the like magic of like, databases broadly, open lakehouses in particular. Mm-hmm. But like I said, like the transition from sort of like data lake to like Lakehouse was storing everything in a consistent format. If you look at how like databases store data on disk, for instance, it gets stored in a file, maybe a collection of files that like is typically like a paginated data structure where the rows are represented like on the page in different way, row 1, row 2, row 3, and they're encoded in a specific way. And then the database engine knows how to work with that storage format. And so like traditional databases are kind of like those two things like put together. And then indeed, like Snowflake and Databricks' offerings work the same way, only they're like column oriented, we say. Instead of storing data in like row oriented, row by row, they store data column by column, which is useful for doing analytical queries, because like if you have to pull out all the rows to scan like a large data set, then that ends up being super wasteful, right? So being able to only pull out the columns that you need to do your work, that's advantageous. You can also apply different types of compression to these columnar formats. But anyway, my point is that like in the sort of modern data warehouse world, there's this data format and this database engine that work together. But the open Lakehouse concept is predicated on like, what if we had our own format? What if there existed a format that you could store all of your data in, that many different engines understood, and it was kind of consistent across the whole Lakehouse. And so there have been a few that have been invented over the years. The winners right now in the ecosystem are Apache Iceberg, Delta Lake, and then Hoodie. But personally, like I spend more time with Delta Lake and Iceberg. There's some Hoodie fanboys out there that are gonna like be really angry with me about that. But that's where I spend most of my time. And if you look at like the way those systems work, Hoodie and Delta, like they look an awful lot like regular columnar. The columnar formats that all of the big data vendors have brought to market. Actually, I don't really know ClickHouse's format and how it behaves behind the scenes, but I would imagine it's very similar.
That is something we will talk about in future episodes. But Iceberg, bringing Iceberg and ClickHouse better closer together is something that we're working on very hard at Altinity.
Yeah, I think all of the vendors are, right? Like it's a big
Yes.
thing.
Yes.
I mean, the invention of Iceberg is actually kind of an interesting thing. These two really smart dudes at Netflix decided hey, basically the open Lakehouse should exist, and there needs to be a format to drive them. And so they sat down and decided, okay, what would this format look like? It ended up looking a lot like, some of the formats that other vendors out there in the world had already published. Specifically, it looked a lot like Delta Lake. But this was like a tool that they could then go to all of their vendors and say like, hey, we really we need to open up our data to the rest of the world, right? And so please support this format. But you get sufficiently many of these big vendors out there, or big customers out there going to vendors, and it becomes this sort of thing. This is significant for the data warehousing ecosystem. In fact, it's almost sort of existential for a lot of data warehousing vendors. The traditional moat that these companies built was your data is once your data is inside of our system, it's very sticky, as we say. It's really difficult for you to switch to another vendor. You have to get all your data out of our system into another system. But now in this new world, where I can just say, hey, I need to use Snowflake for this thing. And I'll use ClickHouse for like my observability workloads or whatever. And I don't have to move any data around. That's pretty scary, I think, for those folks. Yeah. But they're embracing it really well. Yeah. Yeah, it's a whole new world. Exactly. The companies will still exist. They'll do great. It's just like different economics for the business, right?
Yeah. I'm a really huge fan of keeping the data in your own cloud, right? Even just getting it to those vendors in the first place can be expensive if you're going across clouds. And
yeah, absolutely. Actually, one of the reasons that I joined Snowflake originally was right after they had adopted these sort of like the data cloud moniker. And this idea that like you could move your data between any cloud, like using Snowflake, was like pretty powerful. I thought, like, if you were a Azure customer and a AWS customer, and you could seamlessly move your data between these clouds using Snowflake as the backbone for it, that's pretty powerful stuff. Yeah.
That's awesome. Are you familiar with AWS Glue?
Yes, definitely.
Yes. Yeah. So this is. I think this is an interesting for those who are not familiar. It's the like sort of productization of Iceberg on AWS S3.
Yeah.
Is that a good explanation of it?
Well, I mean, I would say that it's like a part of the overall story. Like Glue is many things to many people, but it was like one of the first catalogs, actually.
Yeah.
At least one of the first that I used. Maybe one of the first in the ecosystem.
Sorry. Yes. Glue is the catalog. I'm confusing it with Table Buckets, which is specifically just Iceberg on top of S3.
But I think that they call that. I think that's part of the Glue product suite.
I think that's why
Glue
I got
is many things to many people,
yes.
Or to different people,
Yes.
So it's like if there's an AWS product manager listening, maybe you guys want to think about this. I don't know.
The point I was trying to make is vendors are adopting these open formats, right? And so it's like if I'm looking at this as someone trying to build out a platform, there's build versus buy, but there's also it's almost a matter of degrees now, right? I can choose to have
like a gradient,
these managed services on top of these open technologies that I might then be able to take somewhere else if I want to. So what, like, do you have like a framework for decision making? Like, when do I want to DIY? When do I want to go with a vendor? When, right? What are the trade-offs?
Yeah, I mean, like as an engineering leader, I think the traditional thing is like my traditional sort of framework, or maybe not framework, but rule, is if it's like something that we are good at and it's something that is core to our business, we'll probably build it. If it's not core to our business or we're not good at it, I'll buy it from somebody else. And so that's how, like, I make these decisions. Yeah. But it gets more complicated, like you said, in this world where you can kind of like piecemeal things together versus going out and buying something. Like to take take an example, or to couch the like AWS discussion in an example. Like if I was at a company that had really good chops on managing AWS infrastructure and understood like the ecosystem or just managing cloud infrastructure broadly, then yes, cobbling together a Lakehouse solution on top of AWS would make sense to me, at least as a place to get started, right? If that wasn't part of my core competency and it wasn't something that I either was good at or wanted to get good at, I suppose that's another kind of part of the dimension of the whole thing. Then going and buying something else, like a little bit more complete platform off the shelf, might be the way that I would lean. Is that like the direction you're going?
Sure, I guess. Yeah, that's exactly what I'm asking, and that's a great answer, right? I love that idea of just sort of sticking with what you're good at and what makes you money, and letting people help you.
And I do think you should incorporate what you want to be good at as well, as long as it's not like super like risky to you as a business, Yeah.
So why choose open formats, right? If we're going with a vendor, we've decided this is something that's not one of our core competencies. Does it matter if the vendor is using open formats under the hood, or do we?
Yeah, it's a good question. I mean, like if I was even to go set up like a brand new Databricks deployment today, I would still lean on Delta. or Iceberg instead of using the proprietary formats, just because like the optionality in terms of using other engines on top of that is like super, super important. Likewise, the lift is not that much bigger. A lot of like on Snowflake, and for instance, it's like a single command more or less to like move your data from one format to another format. Pretty sure. But yeah, like adopting open formats is like super important. I think from day zero to get these benefits. It's also one of those things where like you kind of build a muscle around these things, right? And so it looks like a heavy lift at first, but then if you kind of solve these problems early and get used to it, like your iceberg muscle gets a lot stronger. Yeah.
And then those technologies being open, your data is portable, but your skills are also portable.
Yeah,
because,
true.
Yeah,
yes.
Yeah.
Yeah, exactly. And because, when the next like evolution of, next set of Iceberg features come out or whatever, you're like primed to jump on them or whatever. Yeah.
Yeah. Okay. So let's talk a little bit about Tower and kind of what you're doing with data. I think from what I've seen, Python is probably like the most interesting tool for working with data. I'm reluctant to use it. I don't like the idea that white space has meaning. I do like the idea that all code is formatted correctly. I love that. That part's great. But no. Python is really fun. So, and then I think Tower specifically is a serverless platform, correct?
Yeah, exactly. So like the kind of foundation for Tower was, I'm an American, but I split my time between Berlin and London these days. And specifically when I was in Berlin, I was doing a lot of advising of companies. And there's this kind of like group of companies in Berlin. They call themselves like the data mafia. They're all building data tools, specifically trying to like focused on the Pythonic like revolution in data tools. There's like a new breed of data engineer that is really focused again on the sort of build versus buy thing. They're focused on building new platforms using these open Pythonic tools in the form of notebooks, or typically like in the form of just like Python like code that they manage themselves, right? And so while working with these companies, we found that like a lot of them are really struggling to operationalize the infrastructure around these things. They're great at like actually like the Pythonic side and the data science side of things. Like these guys are like go to like French, universities studying NLP, but like to provision an EC2 instance is like a huge lift for them, right? So being an infrastructure guy, my co-founder and I, we said, okay, like this is definitely a problem that we can help people with. And when we went to market, we kind of found the market behaves in kind of like two ways. Once it becomes time to like operationalize your data engineering work, you can either go pay Databricks $100,000 to use like Databricks is to be forced to use Spark basically, or you can try and build it yourself, build a platform yourself. People reach for things like GitHub Actions, say, or maybe like base things around orchestrators. Like Airflow is good enough, but then they have to build like the whole platform around that. They want monitoring and observability, and they want like collaboration features and all of that. And so what we built is kind of like in the middle between these two options. We have like a serverless Python runtime environment that makes it really easy for you to give us any Python. We'll run it and orchestrate it using our serverless control plane. And then we have a bunch of value add features that we kind of bolt onto the side. Things like, monitoring and observability, secrets and environments management, collaboration features, all of that stuff. So that you no longer have to like either build something or like have to adopt Spark when you don't need it. Yeah. And the reason this is relevant to the like the Lakehouse discussion is that these folks are also like they're the tip of the spear on these Pythonic guys are the tip of the spear in terms of like the next generation composable data stack, we call it. But they're also the tip of the spear on the adoption of Iceberg and open table formats. Like I'm having conversations with folks. It's actually fascinating to watch. Like these companies who are exploring Iceberg, maybe like 6 months ago, hey, I've heard Iceberg is going to like save us a load of time and save us a load of money and make us more flexible, to like go from that to like actually today solving really hard problems on Iceberg. Like, how do we do streaming updates in Iceberg? And so anyway, Tower has a bunch of like integrations with the Iceberg ecosystem to make adopting Iceberg easier for companies and help people onboard into the Iceberg world. Yeah.
Okay, that's amazing. And so are your users really seeing these benefits play out of this sort of like multi-query engine framework, this multi-axis pattern?
I mean, the number one thing that people see, like above all else, is cost savings. Like 10x reduction in their data engineering costs, because you're using like really simple tools that are like super powerful. So that's like the big thing. We're starting to see the engine side become true. You mentioned, ClickHouse is starting to add support for interoperating with Iceberg. That's kind of the case for a lot of vendors in the ecosystem right now. Some are further along, some are further behind, but it's like starting to become true. Yeah. So the other big shift, I guess, in this whole in the Iceberg ecosystem right now is standardization in terms of how metadata is stored for Iceberg tables and open lakehouses. People are starting to standardize on like Apache Polaris or Lakekeepers, another company that we work really closely with that I really love for maintaining the metadata that's in your for your data lakes.
How is that different? Yeah, wait. How is that different from what the catalogs are doing? Aren't the catalogs maintaining the metadata?
It's the same thing. Yeah, catalogs. Catalogs are metadata, and the catalog services that are out there. So Glue, you mentioned Glue has a catalog service. If you're in the AWS ecosystem, Glue actually has like a couple of catalog services. Like they have like a semantic layer catalog service, and they also have a Iceberg catalog service. So it's kind of weird. But they're specialized vendors in the ecosystem, like Lakehouse I mentioned a moment ago, who is like really focused on solving like the metadata problems, the catalog problems for open Lakehouse tables. Like to couch it in something more practical for people listening, like a database engine I mentioned, has like the storage, and then it has the compute for actually running the queries. There's the thing that connects the storage to the compute is the metadata layer. It says like, what columns live in what files, and when was the last time a relevant file was updated, such that I should, which file should I go to get the latest information. All that's stored in the in a traditional database we call it the information schema database, but in general it's kind of like we're in the metadata broadly. And Iceberg has gone through kind of 3 evolutions with regard to metadata. They said at first, okay, just keep it in another file, everything's a file, great. The second evolution was like the semantics of updating files in a distributed context is pretty difficult. Why don't let's use a metadata store. So like there's implementations of this on top of, pick your favorite distributed database, Dynamo, I think Hive or HDFS and Hive have one, loads of different ones. And then the third sort of evolution now is what they call REST catalogs. So they publish sort of an open API spec that says, okay, if a catalog conforms to this open API spec, it does all of the things that we need to do. And so like a lot of the complexity around like concurrent updates and everything gets pushed into these catalogs. And yeah, for the third time, I will plug Lakekeeper. They're my favorite guys in the ecosystem right now. Yeah.
I can say from first and secondhand experience that updating catalog files on object storage is challenging, because that metadata gets updated often.
Yes. Yeah. And, way more often than you might think over the course of a single transaction.
Yes. And yeah, so keeping it in object storage is a challenge for sure. So having abstractions on top of that is great. Okay, you may have kind of already gotten into this when we were talking about Tower and your feelings on why you started Tower, but like if you had to say one thing, what's like the thing that's still fundamentally broken about the developer experience around all of these tools?
Yeah, I think it's kind of like how we're in this the humanity. This may be a bit broad or grandiose, perhaps, but humanity is in the middle of this transition from a world where like your computer is on your desk or like in front of us to your computer is in the cloud. Right now, it's a combination of those two things. Like we use cloud services from our devices locally, and the portion that's in the cloud is growing, and the portion that's on your desk is shrinking. And modern applications are used kind of using both of these services, right? And the developer experience around like leveraging both at the same time, working with the cloud from your laptop, is still pretty broken. I think there's a lot of overhead in terms of management. Like you as a developer get the same tools as like the ops guys who are like running these applications, you know, and you still have to deal with like flaky networks and that sort of stuff, you know. So I think the developer experience is broken in this ecosystem, and I think the solution is a combination of like bringing the developer experience more towards the cloud, more to the cloud, and bringing the cloud to the device that you're working on as well. Or maybe that's it. Maybe that's the solution. Bringing the cloud to the device you're working on, but the device you're working on could be in the cloud itself, you know? But anyway, giving users or giving developers the same experience in like across both platforms is like the core thing. We've spent a lot of time thinking about this in Tower. And I think a lot of people don't spend enough time. A lot of dev tools companies, ironically, don't spend enough time thinking about this type of stuff. Yeah.
Yeah, I feel this so acutely. Like that really resonates with me because, you know, even just the experience of like, oh, I have a Docker file. Oh, now I need my manifests. And right, just the packaging, let alone the tool chain of how I'm actually running the thing and testing it and yeah. And like it's kind of like this thread that you like start pulling on, right? And it all kind of falls apart like over time. Like not enough people are thinking end to end about the whole experience when they want to use like you know, their tools or whatever. Yeah. Okay. So what do like it can be part of the solution to that or just something else, but what do you see sort of defining the next 3 to 5 years in this space?
Well, I think it's still like a real fight about like in the open table formats side of the house in terms of who's going to quote unquote win. Like the Databricks has a huge quote unquote dog in this fight, I would say, because the company that backed Iceberg, they purchased last year for like $2 billion or whatever. And they got a lot of the talent that was kind of focused around. Iceberg is fundamentally owned by the Apache Foundation, right? And so there's a lot of like the community that drives the decision making around like the direction that Iceberg should go. But vested financial interest lies, you know, with Databricks pretty heavily. So I think like there's going to be a lot that evolves in that sort of side of the ecosystem. Yeah. And I also think that the pressure is going to continue to mount on the vendors to support Iceberg. Like in my mind, I think in like 5 years, like I think Iceberg, maybe it's something else, I don't know, but there's going to be an open format that everyone has to support and speaks. And it's like going to change the way that we use all of the data tools in the ecosystem. And it's going to be a fundamental tool that data engineers need to have in their toolbox to like work with these whatever the winning or maybe a few winning open formats are. Yeah. And my tinfoil hat maybe prediction for the whole thing, if I was to put on a tinfoil hat, is that I think Delta and Iceberg are going to converge at some point. Like both of them are kind of adding features out of the other's camp. And so maybe like Deltaberg or something like that is going to be the like winning format in the future. But I don't know. Again, there's lots of people who are much closer to this than I am, so I'd listen to
I
them.
love this. I love this vision. I also feel for the engineering leaders right now. The title of our episode is "Why You're Rebuilding Your Data Platform Again."
True.
So
Yes.
that's me right now. I'm an engineering leader forced with rebuilding my data platform. What would you tell me? What advice would you give me? I don't have 5 years to wait for these data format wars to resolve. I need to pick some tools now.
Yeah. I mean, like, I would say like pick one and focus on it, you know? And I would pick Iceberg and focus on it and build your business around that. I don't think it's going anywhere. And I think it's like there's enough momentum in the ecosystem to like around the vendors supporting it that like you've got a good like probably 3-5+ years of runway to sort this out. I'd also say that again, like I mentioned earlier in the episode, paradigm shifts are what are the drivers for changes in our data platforms. We're going through this big AI paradigm shift right now. Whatever the next one is going to cause another, another shift to happen in how data platforms are. So one thing that I tell engineers oftentimes, maybe I should tell engineering leaders too, is maybe like Buddhist data engineering. Everything is temporary. We will throw everything away eventually. So if you are stressed out because you have to build your data platform again, try not to be.
Good advice. I love that. I might have to get a Buddha board for behind me to represent the Buddha database, the Buddhist database.
Yeah, there we go.
All right. So let's imagine I'm someone else. I'm brand new to this. I haven't been through the last decade of lessons. What would you do? What advice would you give to someone just starting out with data at this scale?
I mean, it's probably one of the best times in the history of like the practice to be getting into the industry. There's like so much happening now, and it's established now as like a concrete like practice. The concept of data engineering didn't really exist, in 2015. Like data engineer as a title didn't really exist 10 years ago, or maybe even less than that, right? So it's really exciting because there's so much going on. I would say stick with Python. Python's going to be the way forward. So like if you're going to invest in learning a skill, that's the one to learn. I would say don't be afraid of the data science side as well. Like the role between data scientist and data engineer is kind of blurring inside companies more and more. So don't be afraid of that as well. And similarly to like the engineering leaders, like front load your quote unquote education in the open table formats because it's going to unlock your ability to work with loads of different tools today and going forward. Again, like this ecosystem is moving so fast that like, in 6 months, we could be having a completely different conversation about like the relevant support in the ecosystem, right? So, yeah.
Okay. I love it. Great advice. Okay. We're getting towards the end. We'll wrap things up shortly. But
Sure.
Before we do you have any spicy opinions or like just a really controversial opinion for the topic?
Yes. I mean, I already gave my sort of tinfoil hat theory that like I could potentially see, Iceberg Delta converging at some point in the future in some way. Just like the way the ecosystem's behaving. I don't know. Let's see. And like the features that are getting added and everything, like to Iceberg in particular, are looking very Delta-y, So let's see. The other one that I think is like really upsets people is that I think, we talked a bit about people with like on-prem data and like this transition to the cloud. We've been talking about the transition to the cloud since 2012. I think in 2035, we will still be talking about on-prem data and transition to the cloud. I think there was always going to be on-prem workloads out there in the world. And in fact, I think like in the overall IT spend, like cloud still accounts for increasingly more of it, but still only a portion of the overall IT spend. So I think like on-prem is not a thing that like is going away, but I think it's defined a little bit differently. So yeah, that's maybe it'll spawn some discussion. Let's see.
I like that a lot. I don't know that that's that controversial. I agree. It's,
Great, good.
Okay. Do you have any closing thoughts?
Yeah, I mean, I think that it's like I said, it's a really exciting time to be in the ecosystem because things are changing and moving so quickly. There's loads of attention on the space and loads of money being put into the data ecosystem as well. And a lot of the stuff around, data is oil, et cetera, is like coming to fruition, right? So it's great. I'm looking forward to seeing how, things evolve. Maybe we'll do another one of these in like 5 years and, see what's new. Yeah.
That'd be amazing. Kubernetes 2.0 will be a thing by then.
Can't wait for Cube 2.0 to drop.
Yeah. For anyone who doesn't know, that's a joke. It's never coming. All right. So is there, what is the most exciting thing you're doing right now at Tower?
Yeah, I mean, I think it's the thing that I think is the most fun is trying to address this like on-prem to cloud, this kind of hybrid deployment like scenario. So like Tower is divided amongst we have this globally distributed control plane that manages all the orchestration and all of that. And then our data plane like runs in our cloud, or you can download and run the data plane in your cloud. And I'm really enjoying working with our customers to like debug all the problems in their in their like data centers and all of that. And just operating software in a slightly different way than I have for a while. So I think that's really exciting. And some other folks are pretty excited about it too.
I agree. All right, that's great. Anything you'd like to plug? Where can people find and follow you?
I spend most of my time on LinkedIn these days, for better or for worse. in/BradHE, you can find me there. Or you can find me on GitHub, also BradHE on GitHub. I would love to have
That's
more.
the nerdy way.
Yeah, exactly. I'm still there. Otherwise, check out tower.dev to learn a little bit more.
Okay, awesome. Well, we will be back next month. We'll have a schedule posted shortly. Brad, thank you so much. This has been an awesome episode. And yeah, thank you.
Yeah, thank you. Chat soon. Cheers.